The next lecture is actually some information on doing a statistic called a chi-square in version 9 of the textbook, chapter 17, version 8. It's chapter 18, and I want to do a little example for you for the chi-square. Let's say that I did a study, just randomly stated here, that I was interested. I took a poll of 100 people, and I asked the 100 people, are you scared of statistics? Do you have, my made-up name here, statisticsophobia? So let's say that was the nature of the study I was interested in doing, and I had 100 people, and I wanted to figure out, were they scared of statistics or were they not? So let's say, for the sake of example, 90 people said they were scared, and 10 people said they were not. Now the key question here, is that difference statistically significant, or could that result happen due to chance? Now what's your gut level kind of saying on that idea, 90 versus 10? Hopefully your gut level is saying, yeah, that could happen due to chance, but it's very unlikely. There's a really much greater chance that that is statistically significant. So we're going to learn to do the statistic that's going to allow us to compute that. So 90 and 10. Now if you look at the formula and see, and it's in your textbook as well, it gives you the formula of the summation of FO minus FE squared over FE. And so the big question is, what do those FOs and FEs stand for? Well, FO stands for frequency observed. FE stands for frequency expected due to chance. Now in this example, we actually have two FOs. What frequencies did we observe with this particular data set? The frequencies we observed, the two FOs, were 90 and 10. That's observed by the sample that we had here. So we had a 90 versus a 10. Frequency expected due to chance. Now, how do you figure this out? The frequency expected due to chance. We have a total of 100 people, and there are two categories. So if there was no significant difference, what would be the frequency expected due to chance? Well, 100 people in two categories, the FE, if you haven't figured it out at this point, is 50. Because that's, 50 and 50 is 100. So if there's no difference, you would expect the frequency to be 50. So what we have to do are some computations based on this. And I am assuming, because algebra is the prereq for this, that you can do some basic level computations here. So we would start off, as the the agenda says, with the first FO, 90 minus 50 squared. And then you'd actually put that over 50. And then you would do the summation sign, plus 10 minus 50 squared, and you'd put that over the 50 as well. And so if you do out the math with that, the 90 minus 50 squared, that would be what, 40 squared. The other one would be the negative 40 squared. So you get what, 1600 and 1600, and then you divide that sum by 50, and the result you should get from that is both a Beatles song and the year Dr. Tausman was born. See if you can figure that out. So that is the result. Then the question is, okay, you get a result, and is that result statistically significant? So your book actually has a chart to let you figure this out. If you turn to page 711 or 738, depending on the book that you have, you can see there's a chi-distribution chart on that. And what you have to do is you have to look for the degrees of freedom. So if you have two categories, you have 1 degree of freedom, because it's always number of categories minus 1. You look for degrees of freedom 1, and then you look for proportion in the critical region. We always go with the 0.05. So the critical value that we always use is 3.84. So if our result is greater than 3.84, which hopefully it is, because I think you figured it out that the number was 64, our result would be considered statistically significant. And actually, if you even went to the 0.01 value, we would still be statistically significant, because the critical score for that one is 6.63. So our result is definitely statistically significant. The way you write that out in APA format is you write the little chi-square formula, and then in parentheses you have degrees of freedom. So what are the degrees of freedom here? If we have two categories, you'd write chi-square, and then parentheses 1, comma, n equals, what's the n value here? 100. Then you'd write equals 64, and then you could write p less than 0.05. So this result is statistically significant. What real-world conclusion would we reach here? The real-world meaning would be that people definitely are significantly scared of statistics. 90% of the sample was scared, and that is considered statistically significant because you're above this critical score. Now, let me give you the other example, and maybe you can actually even do this out with the computations. What if it was 51 scared and 49 were not? Well, what you would probably get there, actually you don't have to do out the computation, but you can just think about it for a minute or two. If it was 51 and 49, what kind of chi value would you get? You'd get 51 minus 50, you get 49 minus 50, both over 50. You'd get a very tiny chi obtained value, and it would not be statistically significant because you're pretty close to chance there at 50 and 50. So hopefully this explains the idea of how you actually do a chi-square, get statistical significance, and the meaning behind that. So let me finish this off by kind of giving you the setup with the homework. Now, I've never done this particular homework assignment before. You're going to be asked to watch a study. It's a little 2-minute study with the YouTube. It's an ASH conformity study, which I'm hoping some of you may be familiar with. In this study, they had a group of Confederates in the room, and they asked people to look at one line and 3 others and make a judgment of what that one line was most similar to, which one it matched. And it was very obvious what the right answer was. But they had 5 other people in the room. The subject thought that they were all just subjects like him, but they were hired by ASH to be Confederates, to purposely give the wrong answer. And they would give the wrong answer first. So what I'd like you to do is just watch the little video for a setup, and then I've created a data set situation for you saying that let's pretend that 100 participants were tested one at a time with the 5 Confederates in the room, and that 30 participants gave the right answer, but 70 actually gave the incorrect answer, the ones all the Confederates said. What I'd like you to do is compute a chi-square on the basis of that and figure out the statistical and real-world conclusion. And finally, I have one homework problem from either Chapter 17 for version 9 or Chapter 18 for version 8. It's a chi-square problem on home team advantage. So see if you can do that problem, compute it, and then if you want to send me a draft, both of basically one draft of the syllabus outline and highlights of what I talked about verbally, another one on this idea of statistical significance, and then the third one, which is on this idea of the chi-square and the homework, then you can send me a draft of these things for up to 5 days, and if it's more than one draft, that's fine, and then post it by the time we either have the live conference call on June the 1st, is it? June 1st or 2nd, the Monday, next Monday, or you conference call in, or you show up. So hopefully this is clear, and good luck with your work. Thanks. Bye-bye.